Example 7. We're going to use differentials to approximate the square root of 16.5. So we're going to figure out the approximation of this radical without using a calculator. Okay, so we know that delta y is approximately dy, and the approximation is a better approximation as dx becomes smaller and smaller. So we know that dy is f of x plus delta x minus f of x. And we know that dy is f prime of x dx. We're going to use this as the approximation. This would be the actual amount. Okay, so how we're going to do this, we're going to let f of x equal the square root of x, and let x equal 16, and delta x, or dx, equal 0.5. Notice that if I took f of x plus delta x, that would be f of 16 plus 0.5, which would be equal to the square root of 16.5. Okay? Okay, so again, we've already said that delta y is approximately dy, where delta y is this f of x plus delta x minus f of x, and that's going to be approximately equal to dy, which is f prime of x dx. Now, f of x plus delta x, that is the square root of 16.5, minus f of x. F of x would be f of x would be equal to f of 16, which would be equal to the square root of 16, which is approximately, let's take the derivative of f of x, so the derivative of the square root of x. Notice that the square root of x, we can write that as the x to the 1/2 power. So the derivative of f of x would be 1/2 x to the negative 1/2 power. So 1/2 x to the negative 1/2 power dx. And we know that dx is 0.5, or 1/2. So now we have the square root of 16.5 minus, that's going to be 4, is approximately 1/2. And let's see, this is going to be 16 to the negative 1/2 power times 1/2. Then this would be 1/2 all over 1 over 16 to the 1/2 power times 1/2. This would stay the same. Then 1/2 times 1/2 would be 1/4. The square root of 16 is 4. So this is going to be 1/16. And then I'm going to move 4 to the other side by adding that to both sides. So now, square root of 16.5 is approximately 4/116. And that's a close estimation. It's not exactly the square root, but pretty close. And the smaller dx is, the better the approximation would be. Let's try another one of these. Okay, example 8. So again, we're going to use differentials. We're going to use delta y is approximately dy, where dy is the same thing as f of x plus delta x minus f of x, which is approximately f prime of x dx. So the first thing I'm going to do, I'm going to let f of x equal the cube root of x, and this time I'm going to let x equal 27. The reason why I want to pick 27 is I want to pick a number where that's going to work out perfectly. So the cube root of 27 would be 3. And I want to pick a number that's close to 26. Then dx or delta x is going to be -1. So now let's do this problem. So f of x would be, let's see, x is 27, f of x, or delta x is -1, minus f of x, which would be f of 27, equals, so I need to get the derivative of f of x. So let's make f of x equal to x to the 1/3 power, where if I take the derivative, that's going to be 1/3 x to the -2/3 power. So this will be 1/3, and x is 27 to the -2/3 power, dx, which is -1. And then I can start simplifying this. So this would be f of 26. F of 27 would be the cube root of 27 equals 1/3. This would be 1/the cube root of 27 squared times -1. So f of 26 would be the cube root of 26. The cube root of 27 is 3. This is going to be 1/3. 1/the cube root of 27 is 3. Then I got to square that. Minus 1. Let's see here. This is going to be 3 times 3 times 3, so this is going to be -1/27, the cube root of 26. I'm going to add 3 to both sides. So the cube root of 26 would be equal to 2 and 26 over 27. Right. And that will be your answer.